and I'll
Because-
specify the angle.
Let's just say is what you're saying to the midpoint of that? Because here's what I was imagining. Let me just
Okay, you
sketch
tell
out
me
real
what
quick.
would work, what you're thinking.
Let's say that that's there.
That's what?
And I wanted to come up with whatever degree. You can take something like this and actually trace it off and print a full-scale picture, so you can set this on there. So I have a protractor as well, but they're not as,
Okay.
sometimes they're kind of problematic. You can actually kind of evaluate your angle.
Okay,
figure out-
that's,
figure it
that's
out,
good, yeah.
Right.
Right, so we
So,
can.
so let's say I need to make a bunch of those.
Mhm.
I can now set this, it's called a T-bevel.
And that'll lock.
And
Then
get
you
this
lock it.
locked.
Got it.
And now I can transfer my mark, but let's say that's
From
the
your
cut.
mark, right,
So
from the
now,
leading edge,
and this
yes.
is what I was kind of talking about with Roman a little bit. Let's say this is what we need to target. That's what's critical.
Right,
Okay, so now this is on our side view. Look at, we're gonna cut right through the hole. Right, so when the next piece comes in, it's also gonna have a hole there, I guarantee, because of the same thing. So what's gonna happen is, when you start to weld this, we're gonna weld to here, stop, you're gonna have to weld to here, stop. At some point, I recommend trying to fill this hole. And I'll show you some tips on how to do that. We can actually build a little mound around here, and then let it cool for a half second, then go back in and fill it up. It's gonna add a little strength. Not only is this bandsaw on a horizontal orientation, but there's something else happening. On that bandsaw that you might be familiar with, what's happening, the blade's turning and you're moving your part through the thing, right? So the blade's moving, but it's in a stationary fixed position. Here what happens, we're going to clamp your material into a locked position, and what's happening is the head's in motion. And it's pretty reliable. But in a second you're going to see it has a self-cooling system. It basically puts fluid on the cut while you make it. When we look at the dial right here, why don't you come over here and really give us some eyeball. I'm going to count on you guys to be able to show other people, not only be able to do it, but to show other people if they get stuck. It's just a matter of remembering the order. Once you get it, you're fine. This has actually a hydraulic head. Right now the hydraulic, you turn it off, it's on its own position, but it's pretty much stable. It's not going down right now because my lower speed's at 0. So this turns the hydraulic on. This is the rate the head lowers. If I turn this down up just a little bit to,
It'll go really fast.
believe it or not, it's in motion. It's just really hard to see, but it's creeping down. If I kick this up really high, you can see it, right?
Nice.
Your cuts, because I know what the material is going to be, all your cuts right now are going to be at 1.5. Okay? So don't cut it higher. So that's a number to remember. You're going to need to cut your cuts at 1.5 based on your material. This is for the fluid, but right now it's just on. It should always be on. Don't never make a cut without the fluid flowing. You're going to see it in a minute. So this just is on and stays on. This is a stop or emergency off. You just twist it to get it to reactivate. And here I'm going to start now. So here's my blade. My blade's turning, but my head's still on because I got the lower speed at 0. Look what happened. You got fluid flowing. Now you can start to see you can put the head in motion. Alright? Let me shut this off. It's really important because don't try to make a cut without fluid or the blade will break. It'll get hot and break. I guarantee it. We just loaded a brand new blade on there for you. It's going to probably get you through the project if everything goes well. If not, we'll throw a new one on there for you. I know you got a ton of cuts. But right now, the sharper the blade, the more accurate.
How long does one blade last?
How many
You know, it
pieces?
depends on what we're cutting. Say it again?
Let's say, is this material, so how long?
Oh, shoot. One blade's going to last you probably. If not with another. Yeah, I can't really say. It's hundreds of cuts, though. Hundreds and hundreds of cuts. It's $75 a blade.
It's gonna be the same material the whole time, so it'll be smoother.
So we looked at the dial a little bit. Some of the other features of the saw. Hello. You're going to need this. Everyone here should know this. Here's how we can. Right now, it's at 0 set, they call it, or if I put the stock in there, it's going to cut a true 90, because that's what it's set at. If you're going to slide very easily, right? So we can slide it down, and if you look down here, it has a little dial, but like most equipment, it's not really 100% accurate. Don't rely on that. That's what I'm saying. Draft them out, and I'll show you some tricks on how to line it up real nice. Get it really close, right?
Do we know if it like measures just a little bit before or a little after?
Technically, it's slightly before.
Okay.
It's like shy of a degree or two.
Okay.
But I can show you some tricks on how to sight it, and it's probably a little more accurate if you sight it. If you guys get really critical, I think you can always do. Here's a technique I do all the time. Let's say this is your stock. You got to like really watching you know, being economic with the material, you don't want to do a bunch of miscuts. That's a whole other thing. Whoever's doing the layout, that's probably one of the most critical things that are going to happen in this group. Because you cut, you know, if somebody doesn't realize it's a mistake and you cut 40 pieces wrong, it costs a lot of money. So someone doing quality check, you know, and laying it out, checking twice. Here's something you might do. Maybe multiple cuts at the same time. Like I said, if it's I think in your design there's several ones that are 90 on either end. We can stack 4, maybe even 6 at a time. Let me see when we get there. We can cut 4, advance your stock, cut 4 more. 10 cuts, you cut 40 pieces. It goes quick.
Nice.
Right? But here's the deal. You cut 4 and they're right, excellent. But if you cut 4 and they're wrong, you cut 4 wrong pieces, right? That's always a trade-off. So, but I think when we're doing it, that's for the 90 degree. When we're doing the angles, hey, stick to 2 at a time. You can get a better result.
Okay.
Right?
Yeah, we have a lot of angles.
Yeah, I know. That's going to be a challenge. And I think that you should probably have like 20% extra stock within your budget because it's, you know, it's a learning process. Right behind you, there's a pin, that pin I brought. They're not in contact. But now, looking up, before the head was higher, I couldn't really see it. But now, I can really evaluate it in relation to my line. And my eyes telling me now this needs to continue to move that direction. Yeah, is it 5? Oh, there it goes. A little bit more right there. One little tap more. Right there. Now here, come here, slide it from here.
This is done by hand, there's no mechanical adjustment?
This wasn't back all the way, sorry. Here, can you just push that all the way? I can't really leverage from here. All the way down. There we go.
There's no mechanical adjustment?
What, to change this?
Yeah,
Other than
that's all hand.
That's it, yeah.
Okay.
This is actually, we need to go maybe a little bit more.